Hello everyone, today we are going to discuss the shortest path in grid with obstacle elimination problem. We will discuss about the problem first and then we will discuss about the approach. So in this question what it is asking us to do is that we have to start from 0, 0 and we have to reach all the way to the last box of the grid, that is n-1 box. And we have to find the minimum steps that we have to take to reach from this to this. The only trick here is we are given an additional variable, that is obstacle or k. This represents how many obstacles we can skip at the end of the day. If we are starting from here to here and our k is 1, that means out of these 4 bricks we can skip one of the bricks, and then now tell me what is the minimum steps that we have to take. And if your k is 3, then that means you have to skip, you are allowed to skip 3 bricks and so on. Now if you would have gone through the question, you would have realized that it is a common grid question where either you can apply a BFS question or a DFS approach. In this video I'll discuss the DFS one. I'm thinking of uploading one more video where I'll discuss that BFS approach of this question. And to be honest, BFS 1 is way easier than the DFS 1, because in the DFS 1 we actually have to apply DP at the end of the day because of the TLE issues that we are getting. But in the BFS this issue will not come. We'll discuss more on this on the later or on the next video. But let's focus on the DFS approach as of today. And I'll give you a walkthrough of the question, how we are discussing, how we are going. So there is nothing new in this question. You have to just reach from one box to another box. You know that okay, at every point I have 4 direction to go to. Either I can go up, down, left, right, and I have to make sure that we are under the grid, we are not crossing any obstacle. If we are crossing any obstacles, let's make sure that we are under the limit. So it is nothing new. We already have solved a lot of questions in grid where we have to reach from one point to another. There are certain conditions to skip, not skip, go in all 4 direction. So same thing, exactly the same thing we are doing in this question. So I'll just quickly give you a walkthrough. There is nothing new in this question. As I discussed, there will be a directional array which will tell you in which direction you will go from the current point or where you are from or where you are at. This condition is actually a very interesting condition which will help you to not get TLE. The same thing I have applied here as well. So this and this are exactly the same thing. Let me tell you what exactly it is. It is saying that you have to reach from here to here. If let's suppose there is a condition, or let's assume there was no bricks at all, then what is the minimum step it will take to reach from here to here? The easiest answer is we will go all the way down and then we will go all the way to the right direction. So the minimum position from here to here is actually the number of rows plus the number of columns, correct? The same thing it is happening here as well. We are making sure that if the obstacle itself, if the k basically represent how many obstacles we can skip. If there are k obstacles that we can skip, and this is actually more than equals to row plus column, that means we can skip all the obstacle. In the worst case, let's suppose they are saying that you are allowed to skip 10 boxes. Then we do not have to traverse at all. We know that okay, we are allowed to skip 10 boxes. And in the worst case, let me assume that this is the box which is there all over the place. Like it is here, all over the place. And I'm allowed to skip 10 boxes at the end of the day. So I'll definitely skip those boxes which are coming in my shortest path. That is this and this. That's all. So we are checking if the number of obstacle is more than equals to my row plus column. In that case, in the worst case, I can skip all the boxes that are there in this particular direction, and I can skip row plus column boxes easily because of the constraint that I have. In that case, the minimum step that I have to take is row plus column. Something similar we are doing here as well. No matter at what point we are in, let's suppose we are at this point or this box, then I'll do the same thing. I'll say that okay, what is the minimum step I need from here to reach here? It is this plus this. Then I'll check if my k is more than equals to this plus this. That means I can easily skip all the obstacles that might come into my way during this time. So in that case, I'll just directly return this row plus column, or whatever the boxes that are restricting us from moving from here to here. That's all. So this is just one condition that I thought of explaining. Now let's see. This is basically a DP solution that we have given. In this DP solution, we are making sure that we are tracking the the row, the column, and the obstacles that we have. Why are we making it a 3D DP and not a 2D DP? Because k can differ. Let's suppose you are asked that what will be the minimum steps from moving here to here. It can vary depending on the k. If your k is 0, in that case you have to traverse through all the way down here. But if your k is 1, then you can skip this one and then you can move like this. But if your k is 2, you can just directly skip all of them and you can reach here. Got my point? So your value will always depend on your k as well. That's why we are using a 3D DP. We are initializing the entire DP with a max value. Now let's see how we have implemented our helper function. We are passing the I, j, obstacles, grid, direction, and DP. All these parameters we are passing. Once we are here, we are checking that if you are out of bound, pass the maximum value. We can't. Why we are passing the maximum value? Because we will need minimum at the end of the day, and that's what we are doing. We are calculating the minimum one at the end of the day. So if a path is not possible from a particular box, then in that case we are passing the max value so that we can override it with the future minimum values. Okay, now let's suppose I was able to reach to this particular box. Row and column. What is row and column here? It is this particular box where we have to reach at the end of the day. So whatever my current I and j is, if it is equal to my targeted row and column, that means I have reached the end. I'll return 0 out from it. Fine. Then there is this condition where I'm checking that if this if let's suppose you are not on the row column, and you are not going out of bound as well, then just check that let's suppose I was at this point, then just check whether I have already calculated this point or not. That's what DP is, right? We just check whether this particular piece of combination is already visited or not. So that's what we are doing. We are checking the particular combination of I, j, and k. If it is not max value, that means it is already visited. And if it is already visited, then there is no need to calculate it again. Otherwise, it will give you TLE. I'll show you that if I do comment this out, it will give me TLE. I am not sure if the test case is with me right now or not. It will work, but if we give a bigger test case, which have like more than 40, I think the limit is 40. Yeah. So let's suppose if I give a bigger grid, then it will fail because you will be repeating a particular piece of code again and again, rather than you can just save it in DP. That's all DP is. People are way too afraid of DP, but let me tell you, DP is just saving the already occurred combination so that when this particular thing is asked again and again, we can just directly assign the saved value instead of going again and again and calculating the whole thing. So that's one thing. Now this if condition we already know, we already discussed that, okay, if I'm here, if I have to reach here, and if my k is greater than this plus this, that means at the worst case I can skip all of them. So why not just take this plus this will give me the minimum one. No matter how many particular combinations are there, row plus column will always give me the minimum one. So I'm just doing minus I minus j so that I can consider this exact point. Fine. Here one more thing that we are doing, it's a very common thing. If you see, we have mentioned that the obstacles are represented as 1. So we are saying if there is an obstacle and my k is actually finished, like I had a limit of k that at max you can skip 3 boxes, and I have already skipped 3, or I am out of the safe boxes that I had. In that case, there is no other way. You are stuck at this point. You can't surpass this box now. So in that case also you will return the maximum value for the worst, so that it could be overridden with the minimum one. Else, although you have one, but your k still have those safe values with you, you can you can still skip the boxes with you. So in that case you are doing k minus minus. What k minus minus represent over here, that you will be skipping this particular obstacle that will, and once you skip this, that means if earlier you had three obstacles that you can skip, you have already skipped one here. Now you'll be left with two obstacles, or two obstacles that you can skip. That's why we are doing k minus minus. Okay, now that it's nothing, we are just backtracking. What we are doing, we are saving our grid I of ij value to temp, and then we are assigning -1 to it, so that we can track the visited one or not, that if this particular combination is, if this particular piece of box is visited or not. That's all we are doing, so that we do not stuck in an infinite loop. You could have used a visited 2D array as well, that's on to you, but if you want, you can just assign -1 to it, and once we are done processing everything, you can backtrack and assign the original value to it. That's also one more thing. So now discuss about this part of the code. What we are doing, we are going in all four directions. We are asking them that, okay, give me your minimum, or your after going in all four directions, are we able to reach to this particular combination? What is the minimum steps that you can give? Once we get the minimum steps out of it, we can just add 1 to it, saying that, okay, from here I was able to reach till here with, let's suppose, 5 steps. Now if I have to see that, okay, if I would have chosen this piece, I would have reached to this using 6 steps. Now add 1 to it, which means that we will be considering this box as well. So we are just adding 1 to it, so that we are considering the current step as well. That's all this question is about. So there is nothing new if you go through this question. There are just some extra if conditions that we have to take care of. Other than that, everything is very similar. The only tricky part is DP here. You have to realize that it is a 3D DP question. It is not just I and J. You can't assume that this will give you the same answer again and again. No, it will depend on your K. If your K is 0, the answer will be different for this box. If your K is 1, 2, 3, 4, the answer will differ. So that's all, I think. If we quickly discuss about the time complexity and space complexity. So in the worst case, what you will do, in the worst case, you will have to visit all the boxes, correct? And for each box, you have to reiterate, or you have to visit these boxes depending on the K as well. So your time complexity is O of, if I say the number of boxes is equal to n, so your time complexity will be O of n cross k, where k represent the number of obstacles that we have, and n represent the number of boxes we have, because in the worst case, we would have to reach this box with all particular combination of k. So that's why our time complexity is n cross k. If we talk about the space complexity, and in the space complexity, I will not consider the space that the recursive call is taking. I will consider the DP space, that is again a number of boxes into k. So that's where our DP comes in. But if you consider the stack or the recursive stack space as well, that will again increase your space complexity, and you will see that if you start from here, in the worst case, you will have to traverse through all the n possibilities. So that's your space complexity. In the worst case, it will be n cross k. That's it. I'll upload one more quick video with explaining the BFS solution. Thank you.